Hi! In this lesson, we are going to dive deeper into different types of algorithms and discuss how to choose the cleanest, most efficient way to solve a problem. An algorithm is simply a repeatable set of step-by-step instructions that tells one how to solve a problem. Think recipes, directions, and computer programs. The question we are going to explore in this video is, can one algorithm be better than another at solving the same problem? In this example of an algorithm, the path that the green car has to take is very clear. The program is two simple steps. Make a right at the second street and take the street down until you reach the far end of the park. What if we were given these instructions instead? Go straight for 4 blocks, take the first exit on the roundabout, make a right at the second street, take that street down until you reach the far end of the park. We would still arrive at our destination, but this algorithm is unnecessarily long. It's not the shortest or clearest path from the starting point to the ending point. Or let's take a look at a Carol challenge you may have completed. Here you can see Carol following an algorithm to clean up all the tennis balls at a park. If we break it down, we see that the algorithm is as follows. Carol moves across the row, collecting tennis balls along the way. Carol then turns around and moves back across the row. Finally, Carol moves up a row and repeats the process. Is this the only algorithm to solve this problem? Is it the fastest? Is it the one that requires the least number of steps? Well, let's take a look at another example. Here, Carol is following a slightly different algorithm. Carol moves across the row, collecting tennis balls. Then Carol moves up the row and repeats the process. Can you see here that while the first algorithm worked fine, this one requires less steps because Carol doesn't have to backtrack across the row? As you can see, there are many different ways to solve a problem. Two aspects that help when comparing algorithms are efficiency and clarity. Efficiency is taking a look at how fast the algorithm is, and clarity is dependent on how clear and readable the algorithm is. These are both important when writing algorithms. If we compare the efficiency and clarity of our two Carol algorithms, not only is algorithm 2 easier to read and follow, but it is also more efficient. Carol doesn't backtrack across the same row every time. Generally speaking, algorithms with fewer lines of code will often be more efficient than those with more. Let's compare a few more algorithms. Take a look at both of these algorithms written in pseudocode. Which is the better algorithm? While both algorithms are fairly easy to read, this first algorithm is more efficient. Even though both of these will turn a person to the right, the second one will take longer and more steps to do it, and may make them dizzy. How about this one? The second algorithm has better readability. Can you imagine what the first algorithm would look like if we were changing colors 20 times? As our programs get more complicated, it's important to brainstorm and think through different algorithms before diving into the actual coding of the program. Let's take a look at some other examples where more than one algorithm can solve the same problem.